Alright, here we have our first lesson of Module 6. This is lesson number 1. It corresponds in the book to section 8.1, so your notes may have that on there. We're going to define some terms, and our learning target today is to be able to add and subtract polynomials. So before we can add and subtract polynomials, we want to define what some of the pieces are that make up a monomial, or a polynomial. And the building block of a polynomial is a monomial. So a monomial can be defined as a real number, a variable, or a product of a real number and one or more variables. So let me write that out. A real number, a variable, or a product of real numbers and variables. And one or more variables. With, and we have to have whole number exponents. So I know here in Algebra 1 you guys have not dealt with fractional exponents, so we don't have to worry about this so much, but it is part of the definition. And the degree of a monomial is going to be the sum of the exponents of its variables. So in example 1, we're just looking at 3 different monomials. So here we have 5x, which is a number and a variable, or a product of real numbers and one variable. Here I have a real number 6 and a bunch of variables with whole number exponents. And then number 4 is just a real number. But what is the degree of each? Well, that's going to be the sum of the exponents. So in A, 5x, we can imagine that that x has an imaginary exponent of 1. It's x to the first power. So the degree of 5x is just 1. The degree of 6x cubed y squared, we would have to add the exponents, so that's got a degree of 5. And then there are no variables with exponents in letter C, so that has a degree of 0. A polynomial is just a monomial or a sum of monomials. And one more definition before we can start doing some work. We want to have standard form of a polynomial. And so you're going to see me write all the problems in standard form, but that simply means that our variables are alphabetical from left to right. And our we're going to look at one variable and we're going to put it in descending order. So we're going to take the highest power to lowest power. From left to right. So we're going to classify different polynomials based on the degree of the polynomial and the number of terms. So when I say the degree of the polynomial, I mean the same degree as the monomial with the greatest exponent. Alright, so let's take a look. First we have a constant. We have the number 6. So it has a degree of 0, and I just used the word, it's a constant. It doesn't have any variables. It has one term, so that makes it a monomial. 5x plus 9 has a degree of 1, and it is a linear equation. And it has 2 terms, so that makes it a binomial. So anything to the power of 1, when I graph it, it's going to make the shape of a line, so we call that linear. 4x squared plus 7x plus 3 is its highest exponent is 2. So I say that's the degree of the polynomial, and it's a quadratic equation. Anything with an x squared is called a quadratic, and it has 3 terms, so it's a trinomial. 2x cubed has a degree of 3, so it is a cubic. And it has 1 term, so that makes it a monomial. So we can classify by degree, it has special names, and then by how many terms it has special names. And 8x to the 4th minus 2x cubed plus 3x, the highest power is 4, so the degree of that polynomial is 4, and we call it quartic. And it has 3 terms, so that is a trinomial. So I want to write each polynomial in example 3 into standard form and then name it based upon its degree and its number of terms. So I'm going to go from left to right with my highest powers. And there's 2 terms, and the highest one is a squared, so it's a quadratic binomial. And letter B, I've got a 5x cubed is the highest, and then 4x and 7x are like terms, so I'll combine those, so that makes 11x minus 1. So it's a cubic because it's to the 3rd power and it has 3 terms, so it's a cubic trinomial. So here we finally have a try it, and now it's your turn. So please pause the video and attempt to name each polynomial based on its degree and number of terms. Okay, welcome back. So what I need to do in letter A is I first need to combine like terms. So 7 minus 9 is negative 2x squared. Here I've got negative 8 plus 11. And then I don't have anything to combine the 10 with. So now I've got it in descending order of the variable, and I've got 3 terms. So this is a quadratic trinomial. And looking at letter B, it looks like I have all x squared. So I'm going to combine all of the coefficients when I combine like terms. So 11 plus 6 is 17, minus 7 is 10. So I still have a quadratic because the highest power is to the x squared, but it's a monomial. Now when we add and subtract polynomials, we're going to start out with adding. We want to add our like terms together. So what I like to do is to line mine up. I'm going to put my x squared, so here I have a plus 21x squared plus negative 140x plus 1900. So I'm going to line up my like terms. And then I'm going to combine them. So negative 7.1 plus 21. Let's see, let me get my calculator. Okay, so I have something different here. Negative 7.1 would be 13.9 x squared, and then negative 180 minus 140 is minus 320x, and 5800 plus 1900 is going to give me 7700. So that's all you do when you add polynomials. You just combine like terms. With subtraction, it's a little more complicated, because we have to distribute our subtraction sign. So I'm going to rewrite this in a slightly different way. First of all, I'm going to show that I'm distributing my subtraction sign, and then I'm going to put all my x cubes together. And notice I had minus 7x cubed. And then I'm going to put my x squareds together. So I have a negative 3x squared from the first one, and then minus 5x squared. And then I'm going to add 5x, and there's nothing to combine it with. And then I'm going to subtract negative 12 and subtracting a negative, we know we can add the opposite. So now, when I combine like terms, I do 1 minus 7, I get negative 6x cubed minus 8x squared plus 5x plus 12. And now it's your turn. Please pause the video and try these two problems. One of them is addition and one is subtraction. So welcome back, and let's do our subtraction first. So I'm going to put all my like terms together. So I don't have any other m cubes. I've got this minus in front of the parenthesis here, which tells me that everything in the parentheses is going to be subtracted. So I'm going to have a minus 4m squared, and there's nothing to combine that with. And then I've got some m's to put together. So I'm going to put my negative m from the first one, and then I have minus m from the second one. And then here I have some constant terms. I've got a 9 minus 12. So to get my final answer, negative 4m cubed minus 4m squared, and then here's my first combination, negative m plus negative m, or negative m minus m is minus 2m. And then 9 minus 12, which turns into plus 12, I get plus 21. My addition problem is much simpler. I just look at what goes together as far as like terms. So here I have 8xy squared and 13xy squared, so that gives me 21xy squared. Here I've got 6xy and nothing to combine it with, and a negative 12x squared y. So if I was going to write it in descending order of the variable, sorry, I just noticed I did 8xy squared and 13xy squared, and I got 21xy squared, so I forgot to put the y in there. So now it looks right, and I want to go in descending order of the variable, so I technically should put my negative 12x squared y first, plus 21xy squared, plus 6xy. And so now you have learned how to add and subtract polynomials. Thanks for watching.